This lesson will show you how VNAV operates during the climb phase. The climb phase starts at the thrust reduction point. This is shown as a height above the origin airport on takeoff reference page 2. This is the point when thrust is decreased from takeoff to climb power. You must make sure that the airplane follows the correct vertical path when you operate in VNAV. Your first task is to verify all FMC speed and altitude constraints. You can add new waypoint constraints on the legs page when necessary. You can also delete or change constraints. And last, your constraints must correctly follow all ATC clearances. Let's look at a typical climb profile after the thrust reduction point. When VNAV is engaged, the FMC commands the airplane to fly a speed and altitude from the climb page. In this example, the airplane climbs at 250 knots until 10,000 feet, and then economy speed to the cruise altitude. Next, let's see what effects a SID has on a climb profile. The departure and the legs page show that the only constraint is an at or above altitude for the first waypoint. The legs page shows the active waypoint, the target altitude, with an A to show the at or above constraint, and the FMC's planned speed at that altitude. The FMC commands the airplane to follow all of the SID constraints and then fly the climb page profile. When ATC gives you a waypoint constraint, you can manually put it into the legs page. Enter the flight level 200 constraint at ELMA. Continue. Constraints that are part of a procedure or manually entered are shown in large font. Estimates by the FMC for speed and altitude are shown in small font. They are not constraints and have no effect on VNAV operation. If the MCP altitude is set to your clearance limit and VNAV is engaged, the airplane stays at the legs page altitude constraint until it is across the waypoint. The pitch mode goes back to VNAV speed, and the airplane continues the climb at the constrained waypoint. The words in the climb page title tell you the source of the target airspeed. Active shows because climb is current or active phase of flight. Econ shows in the page title when the economy speed is the target airspeed. The FMC calculates economy speed from the cost index value you put in during pre-flight. The page title can also show a temporary or fixed speed value. Fixed speeds can come from more than one source. When a fixed climb speed is set, the climb page title shows the target speed. The fixed climb speed is a flight crew selected speed. A speed transition, a speed restriction, or a waypoint speed constraint. Fixed climb speeds can also be shown as Mach values. When the MCP speed window is open and controls the airspeed, The page title shows Active MCP Speed Climb. Modified shows in the title when you make changes to the page. The new data is highlighted until you make the changes active. The active page title now shows the new source for the target airspeed. The cruise altitude value is the same as the one you entered on the perf-init page during pre-flight. It is shown as a flight level if it is higher than the transition altitude. You can change the cruise altitude on the climb page. Put the new value into the cruise altitude field, then use the execute key to make the change active. Change the cruise altitude to flight level 320. Make the change active. The new cruise altitude is set. You can also use the MCP to change the cruise altitude. If there are no constraints between your current altitude and the cruise altitude, set the new altitude and push the altitude selector. The cruise altitude changes automatically. You do not have to use the execute key. Economy speed is the FMC calculated climb speed. You can manually put in an airspeed or a Mach value. Put in a new speed of 300 knots and make the change active.
Continue.
The data field label is now Selected Speed, and the economy prompt is added to the page. You can use economy speed again if you select the prompt and make the change active. The speed transition is shown here if one is applicable. In this example, it is 250 knots below 10,000 feet. The navigation database sets the values for the origin airport. It can also be set on the airline policy page. You can delete the value if ATC clears you to climb at a greater speed. The speed value is magenta when it is the FMC target speed. When you are above the speed transition altitude, the data is removed, and the target speed changes. The speed restriction field lets you enter a speed constraint that is connected to an altitude. Put this clearance into the speed restriction field and make the change active. The target speed is now the speed restriction value. In this example, after you are above 6,000 feet, the restriction is removed, and the target speed changes. Waypoint constraint data shows when there is either an altitude or an airspeed and altitude constraint on the legs page. In this example, the airplane is below 10,000 feet. The target airspeed is the speed transition value. The target altitude is flight level 250 from the waypoint constraint at Elma. When the airplane is above the speed transition altitude, the target speed changes to the next FMC airspeed constraint. After the airplane is across the last constraint, the target speed changes to economy speed. The target altitude changes to the cruise altitude. Waypoint constraints must always be added on the legs pages, but they can be deleted from the climb page or the legs page. Use the climb page to delete the constraint at Elma. Continue. The data field is empty if there are no remaining constraints. The Climb Direct prompt can also be used to remove waypoint constraints. If you select the prompt and make the change active, all constraints are deleted between your current altitude and the lowest of the MCP or FMC cruise altitude. Now push the Climb Direct prompt. The airplane will now climb to the cruise altitude unless you set a lower MCP altitude or add a new altitude constraint. The altitude selector can also be used to delete waypoint constraints between your current altitude and the altitude window. Each time you push the selector, a waypoint constraint is deleted. You do not have to use the Execute key. The transition altitude can be changed by the flight crew. It also changes automatically if you select a departure procedure with a different transition altitude. The FMC altitudes below the value are shown as feet, and those above are shown as flight levels. Maximum angle climb speed is calculated by the FMC. To start a maximum angle climb, first copy the speed into the scratchpad. Now enter the speed into the target speed line at line 2 left. Make the change active. The page title shows the new speed, and the airplane starts a maximum angle climb. During most parts of the climb, the autoflight pitch mode is VNAV speed. Thrust reference is the autothrottle mode used. If the airplane levels off at an MCP altitude, that is not in the FMC. The pitch mode changes to VNAV altitude, and the autothrottle mode changes to speed. Set the new clearance altitude in the MCP window and push the altitude selector to continue the climb. Continue. The FMA changed back to thrust reference and VNAV speed during the climb. When the airplane levels off at a constraint altitude, the pitch mode changes to VNAV path, and the autothrottle mode changes to speed. If you increase the MCP altitude before the waypoint, the airplane climbs again after the waypoint, and the FMAs change. If you do not change the MCP altitude after the waypoint, the airplane stays level and the pitch mode changes to VNAV altitude. To continue the climb, you must set a new MCP altitude and then push the altitude selector. Do that now. The pitch mode changes to VNAV speed and the airplane starts to climb again. The FMC calculates the climb profile from the thrust reduction point to the top of climb. It includes all waypoint constraints in the route. If you level off at a constraint, the pitch mode changes to VNAV path because this is part of the calculated climb path. If you level off at an MCP altitude that is not part of the path, the pitch mode changes to VNAV altitude. During other parts of the climb, the pitch mode is VNAV speed. Altitude only, or airspeed and altitude constraints, can be part of a SID or entered manually to follow an ATC clearance. All altitude constraints are for barometric altitude and must be below the cruise altitude. You usually use the legs page to add, modify, or delete constraints. For your new clearance, cross Hoquiam at flight level 290. Put in flight level 290 at Hoquiam and make the change active. Your clearance has changed again. Put in the new altitude constraint at Hoquiam. The traffic is not a problem now. Delete the altitude constraint at Hoquiam. There are other types of altitude constraints. For example, an at or above constraint. You put this in as the altitude followed by the letter A. An at or below constraint is put in as an altitude followed by the letter B. Some constraints could include above and below altitudes. You can put these in with the higher or the lower altitude first. For example, at or above and at or below is the same as at or below and at or above. If the FMC calculates that the airplane will not be at the correct altitude for a waypoint constraint, a CDU help window message shows, and the altitude error can be seen on the climb page. In this example, the airplane will be 500 feet below at Elma and will not be at flight level 270 until 2 miles after the waypoint. The FMC does not automatically change the climb rate to help the airplane get to the correct altitude. You can set a lower airspeed on the MCP to increase the rate of climb. Open the airspeed window. Decrease the speed to increase your climb rate. If the climb rate increases sufficiently, the waypoint error data and the help window message are removed. This is your new clearance from ATC. Follow the ATC clearance. Set the new altitude. Use the altitude selector to set the altitude. Put in the altitude constraint at Elma. Use the multifunction key and the line select keys on the right side of the legs page. Make the change active. ATC has cleared you to increase your airspeed. Delete the speed transition below 10,000 feet. Make the change active. ATC tells you to reduce your airspeed. Put in the new airspeed. Make the change active. Boeing 787-01 Heavy. Resume normal speed. Go back to the economy climb speed. Make the change active. Boeing 787-01 Heavy. Climb and maintain flight level 270. Set the new clearance altitude. Use the MCP to continue the climb. Boeing 787-01 Heavy. Increase airspeed to 265 knots. Use the MCP to control the airspeed. Continue.